Hey guys, this is the video for section 4, scale drawing. It's the second edition to scale drawings. If you watched one last week, this is the new version. Okay, so our learning intentions are to understand that scale drawings can be used to depict large or small objects, to be able to convert from a distance on a map or diagram to the actual distance in real life, to be able to convert from the actual distance in real life to a distance on a map or diagram, and to be able to determine the scale factor given in a distance on a diagram and the distance in real life. Here is a scale diagram. Actually, it's not, because it's not to scale. Alrighty, so in class we would have watched this video about very small objects to very large objects, and the reason that we watched this was to get that idea that we live in a world of very large and very small things, and that's why we have to think about scale, because we need to be able to understand that. We need to be able to understand, well, how big is something or how small is something, and the ratios involved in that. All right, so you're watching this video if you found the questions 13, 14 and 15 on the pre-test a bit tricky, or this is just an area that you'd still like a bit further revision on. Okay, so when we come to our scale drawings are special applications of ratios. Okay, so we've looked at what ratios are, now we're actually using them. The purpose of a scale drawing is to provide accurate information about the object which has dimensions that are either too large or too small to actually fit on the page. If a scale drawing does have a ratio of 1:1, then the drawing would be exactly the same size as it is in real life. Okay, so when you're thinking about scale drawing, where are you ever going to use this? Okay, well, this is an example of a student that has made a blog. Now, she's looking at skate parks, and in her technical drawing, she would have had to have drawn to scale. Okay, so she's been designing some different skate parks here, and they would all have to be drawn to scale. Now, on her actual artwork here, she's actually missed out the scale ratio, so the photos have not included it, but on there somewhere there would have to be that ratio scale so that people know what they're looking at and how big it would be in real life. All right, so our first key idea. A scale drawing has exactly the same shape as the original object, but a different size. All scale drawings should indicate the scale ratio. So in this skate park, okay, you can see the 3D version there. Over here we can see the scale that's 1 to 300. So any unit on there in real life is 300 times more. Okay, here we've got our maps. Okay, now this is 1 to 40 million. Okay, so that's a pretty big scale, but then we know that because that's a map of Australia. Okay, and Australia is pretty huge. So on our map, any one unit is 4 million times bigger. Okay, so 1 centimetre is the equivalent to 4 million centimetres. Alrighty, here our scale is 1 to 400,000. All right, and the map is a slightly smaller area than that one there, isn't it? Because it's the area of Sydney. Okay, and then we zoom further into Sydney here, and our scale is now 1 to 200,000. Okay, so our key idea 2. The scale on a drawing is written as a scale ratio. Okay, and in that ratio, the first number is our drawing length, so the measurement on our drawing, and our second number is the actual length in real life, whether that's bigger or smaller than our scale drawing. The first number is always what the drawing length is, and the second one is the actual length. So when we look at the picture of the tank here, it's got a scale of 1 to 76. Okay, so what that means is 1 unit on here, 1 centimetre on here, for example, is equal to 76 centimetres in real life. So 1 unit to 76. With our A380 here, we've got 1 unit to 144. So for example, 1 unit on our model would be the equivalent to 144 in real life. So 1 centimetre would be the equivalent to 144 centimetres in real life. 1 metre would be the equivalent to 144 metres in real life. Okay, so key idea number 3. A scale ratio of 1 to 100 means the actual or real lengths are 100 times greater than that on the diagram. Whereas the opposite here, a scale ratio of 20 to 1 means the scaled lengths on the model, on the drawing, are 20 times greater than the actual length. So the second example here is a very small object. You've had to draw it bigger, whereas the first example is a very big object that you've had to draw smaller. So if we think about that, here we've got some squares, okay, and imagine that my square here has been drawn 1 centimetre by 1 centimetre. That's real life, that's my actual drawing, okay. Here I've increased it, okay, and I've increased it at a scale of 1 to 2, okay. So now this is 2 centimetres by 2 centimetres, so I've increased it by double. And here, okay, this has gone down to, this is a 2 to 1 from my original, okay, so it's half the size of the original. Okay, so a map has a scale of 1 to 50,000. How many centimetres in real life does 1 centimetre on the map equal? So it's 1 to 50,000, so 1 centimetre on the map equals 50,000 centimetres in real life. So 1 unit on the map is 50,000 units in real life. So 1 centimetre is equal to 50,000 centimetres in real life. Okay, here we've got a scale of 1 to 300. So we want to know if we've got 300 metres in real life, what is that on the map? So if we've got 1 to 300, 1 to 100, and we know to get to 300 times by 3 multiplied by 3, do the same to both sides. So 300 metres in real life is 3 metres on our map. Okay. All right. Key idea number 4. It is helpful if scales begin with a 1. Okay, then the second number in the ratio can be referred to as our scale factor. Scale ratios that do not start with a 1 can be converted using equivalent ratios. So to convert a scaled distance to an actual distance, you need to multiply by the scale factor. So to go scaled distance to actual, you multiply by the scale factor. And to convert the actual distance to the scaled distance, you divide by the scale factor. Let me show you what I mean by that. Okay, so if we've got an actual distance and we want to get to the scaled distance, we divide by that scale factor. If we've got the scaled distance, we want to get to the actual distance, we multiply. So let me show you what I mean. Okay, so if we've got a map of 1 to 200, okay, and we want to find the actual distance for each of these. So we've got 2 centimetres, so 2 is double that, is double 1, yeah? So we need to multiply our 20,000 by 2. So we get 40,000. Okay, we've got 5 in real life, so we want to multiply our 20,000 by 5. So that gives us our oops, oh, what am I doing? That gives us our 100,000. Okay, so that's our 20,000 times 5. And here we need to multiply our 20,000 by 14.3, which gives us our 286,000. Okay, now an issue, all of these need units. They must have units, otherwise they would all be incorrect. But now with their units, they're all correct. I hope. Okay, now in this case, a model boat has a scale factor of 1 to 500. Find the scale distance for each of these actual measurements. So these are the actual measurements. So we need to divide the actual distance by the scale factor. So here we're going 50 divided by 500, okay, which is going to give us now 0.1 meter. Okay, remembering those units, because in this area, if we don't include our units, we are done for. Okay, here so we've got 75, so we're going 75 divided by 500. It's going to give us 0.15, and we're talking about centimetres this time, so adding that on. 4,550 divided by 500 is going to give us 9.1 millimetres. Okay, so state the scale factor in the following situations. A length of 4 millimetres on a scaled drawing represents a distance of 50 centimetres in real life. So the first thing we need to do is get these two on the same scale. So it's easier to turn the centimetres into millimetres. So we've got 4 millimetres is equal to 500 millimetres. Okay, and we can divide 500 by 4, so that we go 1 to 1 to 5. Okay, so our scale factor is 125 on that one. Here we've got our scale drawings. We've got an actual length of 0.1 millimetres is 3 centimetres. Now 3 centimetres on our drawing, so that's going to go first, but again we've got we need to make the millimetres into a whole number. Okay, so if we multiply our millimetres by, so we've got 3 centimetres to 0.1 millimetres. So that's so mathematically incorrect, it's unbelievable. So we're going to make our centimetres into millimetres. So now we've got 30 millimetres to 0.1 millimetres. Okay, now we need to make that 1. So we multiply that by 10 to become 1. We multiply this by 10 and get 300 to 1. Okay, so this probably should have come before the last key idea, but never mind. This is just having that understanding of conversion to units, conversion of units. Okay, so it's important that you remember how to do this, or you know where to find it. This is really important, could be a key thing that you put into your knowledge book. Okay, so 1 kilometre is equal to 1,000 metres. 1 metre is equal to 100 centimetres. 1 centimetre is equal to 10 millimetres. All right, now how do you convert between them all? So if you've got millimetres, you divide them by 100. Sorry, you divide them by 10. That is nowhere near 100, it's a 10. You divide by 10 to get to centimetres. Then centimetres to metres, you divide by 100. Metres to kilometres, you divide by 1,000. If you've got kilometres and you want to get to metres, you multiply by 1,000. If you have metres and you want to get to centimetres, you multiply by 100. And if you've got centimetres and you want to get to millimetres, you multiply by 10. So let's think about it. We've got 1 millimetre. Okay, now 1 millimetre, no, let's start with a bigger number there. We've got 100 millimetres. Okay, so that divided by 10 is 10 centimetres. Divided by 100 is 0.1 metre. Okay, so remember, divide by 10, divide by 100. And remembering your numbers moving along, so the decimal point looks like it moves. And then divide this by 1,000. So we go. We've now got 0.001 kilometre. Okay. Move that up one more. Cool. All right, let's start off with the kilometre, just the one. Yeah. 1 kilometre gives us 1,000 metres, which gives us 10,000 centimetres, which gives us 100,000 millimetres. Okay, so let's have a look at this. We're going to convert 10,000 centimetres to millimetres. So we're going to multiply that by 10. Okay, so we're going to go 1, 2, 3. That's 100,000 millimetres. Okay, so 10,000 centimetres is 100 metres. All right, and then we've got to divide the 100 by 1,000 to get our kilometres, so 0.1 kilometre. Okay, so just being able to do these conversions is quite handy. Brilliant practice to do. All right, we've got 560 metres, so we are going to divide that by the 1,000 to get to 0.56 kilometres. Remember, it's the number, you say it's your decimal point moving, although it's effectively not. 560 times 100 is 56,000 centimetres, and then that's 560,000 millimetres. Make sure those units are there. And that is the end of your PowerPoint on your video on scale drawing.